All right, let's get started. So welcome everybody to the Istio Networking Work Group meeting. So we have quite a few items again in the agenda. So first, Vadim, I think do you have a demo or a presentation about connecting clusters with Istio for isolation and boundary protection? And then Frank will go over his PR about some definitions around multi-cluster and federation. We'll have another presentation from Lina and Janfei about mTLS adoption, simplification. And if there is time, Josh would like to cover the topic called reducing envoy overhead with kernel offloads. So let's try to do about 15 minutes each. All right. So Vadim, I see you're already presenting. Go ahead, please. We don't hear you. You're muted.
Can you hear me now?
Yep.
Yeah. Okay, good. So I will talk about isolation and boundary protection. There are multiple compliance standards that require isolation of sensitive data and protection of the boundary of isolation. So we have PCI DSS for credit card data. We have FedRAMP for federal data and information. We have HIPAA for health data. And we have GDPR for private data. And PCI DSS is the most explicit standard. It recommends, for example, putting cardholder data environment on a separate network, and it requires using a DMZ. So we have this security architecture. So first we have a DMZ, demilitarized zone. We have back office environment. And we have some sensitive data environments, okay, for privacy data or federal data or health data or credit card data. And we have multiple here levels of defense. We have a firewall between the public internet and the DMZ, a firewall or gateway between DMZ and the back office environment. And we have also a gateway or firewall between inside the back office environment between the sensitive data environment and the rest of the environment. And we also have RBAC inside. So we have inside the sensitive data environment. So we have here security in depth. We have multiple levels of security, several firewalls and RBAC as well.
Can I ask you a quick question?
Sure.
I mean, you're talking about the security architecture. Is it in general, is it related to the IBM cloud? Or, I mean, where, like you say, where do you have it? Just to understand.
Okay. Yeah, the claim is this is a general recommended security architecture for isolating sensitive data. This is what is recommended by NIST standard and by PCI DSS compliance standard and so on.
Got it. Thank you.
Okay. And for example, to clarify, PCI DSS requires performing penetration tests from outside, from the public internet, and also from the inside. So you have to test how your environment is protected from inside as well. Okay, from back office, you try to attack your sensitive data environment. Okay, and the idea is that you want to isolate these sensitive data environments to reduce the scope of the compliance audits, to reduce the risks, to reduce the cost, and you also want to improve security. Okay, so for example, PCI DSS recommends network isolation for cardholder data. It has a requirement for a firewall between internet and the DMZ, between DMZ and the internal network zone. Okay, and also Google Cloud. Let me show you. I mean, all from multiple clouds, Amazon, Google, IBM, they have all these PCI DSS compliance guides, and also this is from Google, for example. And Google recommends using network policies for this isolation. However, for a large customer that we IBM work with, they do not, for them, network policies are not enough, and they want isolation by clusters. And I think my guess is that many customers will actually want to use multiple clusters for different environments. So the idea is to allocate a cluster per DMZ per each sensitive data environment and for the rest of the environment, okay? And what I propose is to facilitate this cross-cluster communication by Istio, cross-cluster routing, load balancing, and so on. Okay. However, the problem is that today none of the 3 documented multi-cluster patterns provide isolation and boundary protection. And let me explain why. So, for example, there is a requirement by PCI DSS that you do not disclose private IP addresses and routing information to unauthorized parties. And NIST recommends do not discover your network addresses. And what I infer from it that in general, the idea is that you should not send endpoint IPs and also telemetry and logs from a cluster with sensitive data to a control plane, Istio control plane outside of your cluster. Okay. So this is the first requirement, and the second requirement is also that you cannot allow an external component to manage your security. So since Istio control plane, I'm talking about now the shared control planes multi-cluster or single control plane multi-cluster, when you have a control plane that controls other clusters, that controls services in other clusters. And so it follows from this requirement that you cannot let an Istio control plane outside of your cluster with sensitive data to manage the security of your cluster. And together with the previous item, shared Istio control planes do not provide isolation and boundary protection. This is my claim. Any questions, remarks on that?
So, Vadim, this is very informative, and it's clearly one area in which we did not look previously, right? Okay. So is this, are you bringing requirements or proposals?
Yeah, so it's both requirements and proposals. Okay, so now let me switch. So once we understand that single control plane or shared control plane, shared control planes, they do not provide enough isolation. Let's talk about the third pattern that is, which is multiple control planes or gateway connectivity or dedicated gateways. So we have, so the corollary is that we, for isolation, we have to have a separate Istio control plane in each cluster. Okay. However, still with the current implementations, we have a single multi-cluster mesh. Okay, we have uniform naming, we have expose all by default behavior, we have RBAC control at the destination services, not at the gateways, and we have common trust. So today, this multi-cluster single service mesh, consider this diagram. At the top, you have a single mesh, and at the bottom, you have the same single mesh split or spread between 2 physical clusters. And we have this pass-through gateway. And the idea here is just to connect these 2 clusters and to form a single logical mesh. So we have uniform naming, we have the same names, namespace names, and also services names. So we have the same foo in both clusters. We have the same namespace NS1 here. And we have this pass-through gateway, and we can create virtual services and to load balance between the local version in cluster 1 and the remote version in cluster 2. And the claim is here that this pass-through gateway cannot provide this isolation. It's the opposite, actually. The idea is to to combine these two clusters into one service mesh. Okay, we have RBAC policies enforced at the destination services, but we do not have restrictions at the gateway, and this is what is required for isolation. And some technical details: this pass-through gateway, it's a TCP pass-through proxy. It doesn't perform TLS termination, so it cannot know the identity of the source. It just sniffs the SNI value, replaces .global suffix with SVC cluster local, and directs the traffic to the cluster by the resulting name. So this is the implementation. Sorry. Okay. Any questions about this pattern? Okay, can you hear me?
Yeah, we can hear you. You were explaining the current thing, right? You're not sharing a proposal yet.
Yeah, sure. Okay, so let me switch to the proposed implementation. So what I propose is to use the standard Istio mechanisms, just regular ingress and egress gateways, virtual services, destination rules, RBAC, use HTTP rewrite to rewrite the path and authority. For DNS, to use Kubernetes selectorless services, just use the standard Istio installations, and to perform ad hoc cluster pairing. Okay, the idea is to deploy 2 private gateways for cross-cluster communication with special certificates and private keys, and these gateways will trust each other, and no trust is required between the sidecars of different clusters. So this is a proposed, say, pattern. Okay, we have 2 clusters. We do not have uniform naming. Here we, for example, can have namespace 1 and namespace 2. We can have different names for our services, foo and myfoo. We have these 2 gateways, let's say, paired. We have trust only between these 2 gateways, private egress gateway and private ingress gateway. And we selectively expose the services. So here the owners of the cluster 2 can decide to expose myfoo, okay, by some path. And the owners of cluster 1 can bind to this remote service, and they can define a virtual service with the local name and to perform load balancing between the local and remote versions. And please note here that the application uses the local name, like foo.ns1 SVC cluster local. The application is not aware that the load balancing is performed between the local and remote versions. Okay, so this is a proposed implementation. I wrote a blog post about it, and I would like to get your feedback. I would like to publish this blog. Okay, so let me switch, sorry, to the blog. Okay. So the idea is that, okay, so this is the initial state. It's 2 clusters with first one, I have book info, product page details, and reviews version 1. In the second cluster, I have ratings, reviews version 2, version 3. And I have these services are in different namespaces, default and book info. And I also have different names, for example, my reviews. Here in the cluster 2, different names, no uniform naming, no common trust. What I do here, I create 2 gateways, let's say paired gateways with the certificates, and they trust each other, these 2 gateways. And then I expose reviews version 2 and consume them in cluster 1. Okay. So let me switch actually to the final. Okay, so here I expose reviews version 3 and ratings, okay, and perform load balancing 50-50 between reviews version 2 and reviews version 3. Let me show you how it looks like. This is book info. just load balancing between the version with the black stars and the red stars. Let me show you. This is what I have in the cluster. You can see the contents, cluster 1, cluster 2. And let me just show you. I will unexpose ratings, cancel exposure of ratings. Let me show you how it looks like. Okay, so I remove the exposure of ratings from service from cluster 2. And now, as you can see, rating service is not available for reviews version 2, but it is available for reviews version 3, which is in the same cluster. Okay. And so what I propose, the next steps, we are going to write automate mesh pairing operator, people in IBM, to automatically pair these clusters, to create these gateways with certificates. And I propose to consider this to be to make it part of Istio, of the Istio multicluster operator. And also we want to automate this exposure and binding of services, and maybe to create another operator. So I would like again to post this blog post. I would like to get your feedback, and then to get user feedback, and then to discuss with you and to consider how this enters the the whole picture of multi-cluster options of Istio. So that's all from my side. Questions?
So the exposure, I didn't get it. Is it purely RBAC controlled or other means?
Okay, good question. So here exposure means that you expose your service at some path at the private ingress gateway, and you configure consumption of this service, okay, at the egress gateway. So here for example, here the service bar calls the virtual service foo and S1 SVC cluster local by local name. And here you configure how the routing is performed to the remote cluster. Okay, so it's two parts here. And also, yes, you have to configure RBAC. You have to configure which clusters you expose your service to.
So it's service entries and virtual services to kind of connect some service on one side to some other service on the other, right, Nadim?
Right.
I think it's an automatable pattern. It's a well-known pattern. So you just pick, I want this service to be exposed here at this name, and then we could easily automate, generating those things.
But this does not has mic. So.
We
right.
already have this sidecar API that attempts to control similar visibility, except it's not necessarily at the cluster level.
So Vadim, a couple of quick questions.
Mm-hmm.
Why do you need to go through an egress gateway? Right, I presume on the ingress gateway on the remote side, you need to trust the certificate authority of the consuming cluster, right? And you said they weren't in the same, strictly in the same trust domain, so they didn't have to have the same CA root.
Right.
So right now on the ingress gateway, I presume on the other side, you've configured another CA bundle to trust the root of the other cluster, which would actually allow it to terminate traffic from either the egress gateway or even any other service within the consuming cluster.
Yeah, okay, so good question. So first, this is actually the requirement of our customer. Okay, so their security people, they do not want this common trust between all the services in both clusters. They want
no, it's only a common trust between all the services in a consuming cluster and the ingress gateway in the receiving cluster. It's not N by N doing it that way.
Right.
Because the disadvantage of doing the egress cluster and having it terminate is you lose the knowledge of what the consuming service identity was.
Okay. So let's say additional requirement is to perform this rewrite. Okay. So the gateway performs the rewrite of the path and the authority. So this is additional, let's say, function of this egress gateway first. And regarding your question about the identity, I think what we can implement just passing the identity in some header. So the egress gateway will pass the identity to the ingress gateway in a header, and the ingress gateway can pass the same header to the destination service.
Okay, but then now we have to do that in a reliable way that preserves end-to-end trust, or at least does it in a way that we consider to be secure, right? Because that's delegated authority, right?
Sorry, what was the last?
Just passing an identity, right, may not be sufficient for everybody.
Yes, maybe, but additional idea here is that maybe if you do not have uniform naming, this identity of one cluster maybe will not tell you much. Okay, so the services in one cluster just may not know, the identities or the names of the services in the calling cluster. See what I mean?
Right, but even with the egress gateway, the ingress gateway on the other side is prevented from reliably knowing the identities of the traffic coming in.
Yeah, so here, for example, the destination services, they will know that they are called by the ingress gateway, so they will trust their ingress gateway.
Right.
The ingress gateway will know that it is called by a private egress gateway that it trusts, okay, and the egress gateway will know that it is called by specific source services. So it's another, let's say, model of of RBAC. And additional point is that in this case we can also switch to access tokens. So we can provide this RBAC by access tokens and not by mutual TLS. So we have multiple options here.
Right. So my general question is, how can we push as much of the RBAC properties into the private ingress gateway, right? So that it reduces its amount of trust on the egress gateway, because, right, that would be an attack point.
Yeah,
right?
Okay.
Like, why is the egress gateway doing authority rewrites, and why is it doing path rewrites when the ingress gateway could do that?
But maybe we don't want to expose all that information outside of the cluster, right?
Right, but having it be in the ingress gateway prevents that information from being exposed.
No, it prevents it from entering a cluster, but it doesn't prevent it from exiting a cluster. So I want to keep my information in, let's say, in the current, current zone. I want to keep it in Europe. I don't want
what information?
Sorry?
What information? Right, I understand we want egress gateway policies or egress policies in general to prevent services from egressing to things they're not supposed to. That's a given. But that doesn't mean that the implementation detail of a service, right, has to be exposed into the consuming cluster, which is what Vadim currently showed, because he was doing authority and path rewrites. Right, that is an implementation detail of the producing cluster.
And also, we don't necessarily need an egress gateway, even if you do the rewrites. So I feel like all the functionality that you are getting from egress gateway can be pushed to the sidecars, including
That's also true, but Niraj, today we have an issue with egress policy, right, RBAC, which we still need to resolve, which is why people are doing this. But again, I think a lot of that policy could be pushed to the ingress gateway.
Yes.
Vadim gave probably a compliance reason why a customer is making them go through the egress gateway, but I'm still not sure why the routing details are not encapsulated on the ingress gateway side, because it is able to do that kind of rewriting, right? Basically what you're saying is there's an ingress gateway whose job it is to expose a set of services to another cluster, and what those services look like, right, is entirely up to the ingress gateway to decide, and the consuming cluster shouldn't know any details or shouldn't perform any action other than effectively treating them as L4-like services that they talk to.
That approach makes the egress gateway totally optional on the other side. It would work,
Yes.
without it. Yeah.
Yeah, okay, so first, just to clarify, maybe here we have this double translation. So myfoo ns2 is exposed as c2example.com ns2/myfoo version 2.
Right.
And you have in the consuming cluster, you have to perform the opposite translation. So you have this translation from foo ns1 svc cluster local to this c2example.com ns2 myfoo v2 path. Okay, so you rewrite this authority and you rewrite the path.
Right, but that's probably, that last one is probably optional, Vadim, right? The cluster that's going to expose c2.example.com blah, blah, blah is probably exposing it as c2 and instead of myfoo because they've chosen a name for their customer to use.
Right.
Guys, just a quick time check. We're about halfway through the meeting. I feel like this should probably be offline in a doc somewhere.
Probably, yeah.
Just one quick question.
There is a PR out for review.
Well, I think we need a doc.
It's a blog post. It's a blog post.
Yeah, but
Well, so there's obviously a fair amount to kind of unpack in here, Vadim. So one, I think, can you share the slides? I put a placeholder in the notes to do that.
And it also the authentication aspects are mostly missing. How do you say? Do you have secure naming? How do you do mutual TLS? What exactly do you trust from the name? Because the namespaces are different, and that needs to have a good story because we cannot tell them, hey, do this, but security is optional.
And then the third thing, Nate and I were having a conversation about tooling to help automate this with Pilot and MCP.
Yeah.
So you could create these special types of ingress gateways that then would act as MCP sources for their clusters, right? So you didn't have to do dual config, right? You could just say, I want to consume services from that, right? Mm-hmm. And then it would import those definitions, i.e. the c2.example.com with all the necessary information. So, right, including what trust domain you wanted to use when you talk to it. And then the customer could choose to use either an egress gateway topology or just direct. And I think that would be a useful thing to discuss as well.
And in general, the egress, choosing the egress or not egress should probably be something that is automated with a mesh setting or because
right, but then we need
to be too verbose about it.
But then we have to come up with a standard for how we want to propagate delegated identity. And we haven't really done that yet.
I know, but long term we may have other options on how to,
Yes, we will probably have other options.
So that's why I want to.
So it's quite clear this will need we'll go through some, iterations, but I don't think we should stop anybody from publishing a blog, right? But then you wrote a PR for a blog, right? So I've seen blogs about Istio that are solving, less or fewer problems.
Well, so I think it's whenever we recommend a solution, right, that is effectively kind of a supported part of the product. So we should feel comfortable with how that solution recommendation lines up with the technical roadmap.
And also if the blog is confusing, because again, there are a lot of names and terms that are not agreed on. I mean, mesh federation is definitely not a term that is agreed yet. So using the term mesh federation is highly controversial in a blog post.
Yeah, I think that's fair, but that's kind of the next topic. I just wanted to try to maybe get some agreement on what that term actually means. But
TOC.
So let's just close on this one. So Vadim, from what I can see, you covered the different roots of trust, right? Like in here, maybe you can rename your blog so it doesn't sound like it doesn't touch on the controversial parts.
Well, so let me just, because Nate has been working on some stuff around terminology, and I know Frank, you have as well. Can you three do a pass over Vadim's blog? And Vadim, in addition, we should talk about the topological things and what we actually recommend people to do, like whether we should start with a simpler model, right, where we don't recommend virtual services on both sides or things like that. We push more things into the ingress gateway, and then we talk maybe about variations which have more complexity in the client but are optional.
Okay.
And if I can raise one more point, in this blog post and in a lot of other places, there is a lot of confusion, about the fact that the current multi-cluster mesh gateway exposes everything by default. And that is, I think, agreed that it's a bug or a missing feature. And we probably need to treat it as a
It's a bug.
As a P0 bug. I mean, the fact that we expose everything by default, and we have mechanism.
Is there an open GitHub issue for that?
I don't know if there is an open GitHub issue, but
there's an AI for you there, Costin.
We should have an
yeah, can we open one to track that? Because part of the reason that I think Vadim has this proposal is because the current gateway connectivity mode that exposes everything by default, which is not really what we wanted from our perspective.
I know, but
I wouldn't call this a bug because I remember.
Oh no, it's definitely a bug.
It is a bug. I mean,
it's absolutely a bug.
So,
but by design.
Right?
It's not design. It's not a design. It was an implementation. The first version didn't have the feature implemented. I mean, we have targeting. We have an API virtual service. You specify the gateway where it is targeted to.
Yeah, I mean, right now it doesn't even respect namespace. Well, I think it might respect namespace scoping, but it's not even clear. That's also a bug.
Yeah, and it's not hard to fix. I see.
Yeah, no, it's pretty much.
That's why I want to prioritize it.
Okay. So, anything more on this before we go to the next? Nope. So before we go to the next, I'd like to actually raise the fourth topic on the list by Josh. So Josh would like us to review the document that is linked in the meeting notes. It's called Reducing Envoy Overhead with Kernel Offloads. So please go ahead, comment in the doc. There will be a formal review in a month or so. Okay. All right. So now we can go to the next one. Which is that, again, definitions for multi-clusters and federations. So I see, Frank, you linked your PR in here. So could you please take over?
Yeah. So my main purpose here is just to get everybody to see this. We don't necessarily have to spend a whole lot of time talking about it here. Let me just. I'd like to get people to look at this PR and put their comments. And Nathan's already done some good stuff there. Added some good comments. My point here is, okay, what Vadim was talking about. He originally was calling mesh federation in his blog, and then because of all the pushback, we don't really know what that is. He took it all out. So if you read his latest version of the PR, Costin, you'll see he took out all the talk about these different patterns and all that stuff. It's just showing here as a pattern. I maintain that pattern is a pattern of combining, it's a multi-cluster because there's multiple clusters in this picture. But people, when you talk about multi-cluster, what I think we're really referring to is a single mesh composed from multiple clusters. And we should be clear. So I'm trying to, with this PR, come up with a concise definition of what we mean when we say multi-cluster, that we do mean a multi-cluster mesh. And then when we're talking about something like what Vadim is showing here, that's a pattern where I would argue we're not trying to create a single mesh. We're taking two meshes and we're federating them. So I think that's why I would say that I would like to call that mesh federation and talk about multi-cluster to mean a single mesh. So basically this PR is trying to make this distinction and just give these terms concrete names that we can all agree on. It's just a glossary entry. In fact, it's not going to get into any details about how the pattern works that we were talking about with Vadim. It's just what fundamentally is this? Is this a multi-cluster thing or is it a multi-mesh thing?
How about addressing the security aspects? I mean, how are they going to authenticate each other and all this stuff? Because that's kind of cornerstone for federation, I think.
Yeah, exactly. And I think
if you don't have a story for that, then probably is wasting time discussing, because again, you need to have an answer about how do you trust and delegate trust and all the other stuff.
Exactly. So that
for federation.
The whole point though is what the patterns are, how we do all that is all irrelevant to the purpose of a glossary entry that says, what does the term mesh federation mean? And I'm trying to, so my PR is trying to just say something, at a very high level. It's a baby step, as I told Nathan, just to try to get, some concrete terms that we could just be using these. And what we mean by mesh federation is a thing that, there is no common trust. We have to somehow connect these meshes together.
Sure, but if we don't know how to connect them,
it's totally going to be information that's in the concepts documentation, not the glossary. The glossary is just going to, put a stake in the ground that this is what we're going to call when we just combining meshes like this, and this is what we're calling. So this PR is really a baby step, and I just like to sort of get people to look at it and try to just come up with an agreed that this is what we mean when we say mesh federation, and this is what we mean when we say, multi-cluster mesh.
Okay. Nate, have you reviewed?
Did you attend last meeting, or did you listen to the recording? Because we had a lengthy discussion about the various dimensions for multi things.
And I know, and I think Nathan's got a PR coming. Well, I guess that Riggs is kind of polishing it now or whatever. That's going to kind of be the concept doc. It's really going to cover all this. But like I said, this is just pretty fun. Like this is really just the basic fundamental difference between, multiple clusters that are combined into a single mesh, and a term for multiple clusters that are multiple meshes and they're being combined. Right. And that's all I'm trying to accomplish in the glossary. Like I said, it's just a high-level description of these things.
So just to tie this together to the coming soon concepts doc. So the concept docs definitely call all of this out now. So it's pretty well articulated, I think, at this point. I am saying for one section that refers to multiple clusters, it's all within the context of a single mesh. There is no talk of multiple clusters across multiple meshes because that's multiple mesh. So that is pretty well spelled out, I believe. And I do use the term when I talk about multiple clusters, I do say AKA multi-cluster. So it probably is worthy of a glossary term at some point.
I think what you're saying is we kind of probably are all on the same page. It's just I'm worried about, when people have multiple clusters with Istio and they're trying to put them together, do they understand that a multi-cluster mesh is what we call this thing that is a single mesh combined? And it's probably all there, but that's why it's a glossary term that we can just point to when we mention multi-cluster. This is what we mean.
Yeah, we should be cognizant of that as we review this concept stock to make sure that we have glossary terms that match. That's just something we should do as a part of that effort.
And then I think the same now applies to this mesh federation. If we have a concise definition of mesh federation, then I think what Vadim was just talking about, he could literally just point to the glossary entry and say that's what you can call it.
But we don't have yet a federation. I mean, we don't have any understanding of what federation means. Everyone has
I think there are definitions out there. You want to pick one, right? The job of the glossary is to coalesce or coagulate around one of these.
Yes.
Right. Whether or not we actually have all the working pieces to implement it or not.
Sure.
I don't think the glossary, I think the glossary intentionally would be a higher level description. It would apply to any pattern of how you implement this. If there's one or multiple different ways of doing it, the glossary entry is just to say what this is, not how the connections are happening, not how, so I think that's the point, just to come up with a term that means, if you look at, well, anyway, I'd like you guys to at least look at the PR and add your comments there. Just read carefully what I wrote. I'm not saying it's 100% correct, but I think if we iterate on it, we just want to say at a high level, what does this term mean, and not anything about how you implement it. What can't be.
At least we need to know that it can be implemented somehow, because if you don't answer the question about identity, how do you manage the certificates? What certificates mean if the naming is not consistent, and how you address things if naming is not consistent? I don't think we can.
So Vadim, in the previous, gave a concrete example of achieving, one example of that.
Yeah, I know.
So there is at least one excellent proof.
Okay.
Right. So I don't want to get too bogged down in the mechanisms, because we know there will be variation in the mechanism.
Yeah.
But be wary that defining mesh federation does involve defining trust domain, and you may go down a little bit of a rabbit hole there.
And naming domains and trust domains.
So we can be a little bit flexible with the nomenclature. We've used the term administrative domain before, right, as a proxy for trust domain, without getting bogged into PKI or anything like that.
And
I would just be. Oh, go ahead. I'm sorry.
Okay, so in reality, we have to go by what the customers have in their real deployments. It's not whether we know how to implement it or not. That's a different question. right? But that shouldn't be driving our like terminology.
Oh.
Go ahead, Nate, your turn.
I was just going to say, we don't currently define administrative domain, I think.
Not concretely, no. We use it as an ambiguous proxy for trust domain.
Yeah, I would just...
There are two meanings for that.
I would just be wary of using it as a replacement for trust domain in text. Maybe we should just start using trust domain now and just have a rough sketch of what trust domain means in the glossary. Does that seem fair?
There are different concepts, really. I mean, it's
right.
The same trust domain and multiple admin.
And I think administrative domain doesn't really come into the definition of a mesh as much as trust domain. Trust domain is really the thing we want to call out, I think.
I feel trust domain is much narrower than administrative domain.
Yeah, right. Administrative domain affects naming.
Yes.
Trust domain just affects identity, right?
Absolutely.
So they're orthogonal, but they coincide all the time.
And naming is identity.
Sometimes yes, and sometimes no. So we might want to define both.
Yeah.
Sure. I would say that the concept docs today, the way they tackle that distinction is they say that meshes, if different parts of the mesh share the same naming and same identity infrastructure, then they are the same mesh, right?
Yeah,
so
I agree with that. Yes.
So if we want to use administrative domain and replace naming with administrative domain, that's fine, but we should be consistent.
Yes,
I think it's fine to say consistent naming and identity represents the same mesh.
Yes. Right.
And it's only when we get into federation do we choose on which term to vary. And is it more typical to vary by administrative domain, like team-wise, right, just independent action, or is it more typical to vary by, trust domain, not common root of trust, right? So Vadim, the customer you're talking to, as a concrete example, on which boundary did they actually vary? Was it administrative domain or was it trust domain?
So they are actually talking about the trust domain, and they want to perform authentication by access tokens, like JWT style.
Right, but was it two arms of the same company talking to each other, or was it the company talking to another company?
It's within the same company.
Right, so it's really logically two administrative domains within the same trust domain.
Yeah. Well,
the naming would be consistent, and you will not have conflict overlapping.
No. Like administrative domains, separate administrative domains mean conflicting naming, right? Because they're not coordinating on naming. But they're part of the same company, so they're part of the same trust domain to some degree or other. They have a parent.
Yeah.
But just to clarify again, they do not want to have a common CA root for the.
Right,
that's okay.
But if their CEO said that they should tomorrow, they could, right?
No, they're security.
Yeah,
okay. So
these are the type of examples, right? We end up looking at, right? Most of their complexity is occurring because they're different administrative domains. Some of their complexity is occurring that they don't have a common CA root, but it's not the majority of their complexity.
So, but Louis, I don't think you have convinced at least me that trust domains and administrative domains are completely orthogonal. It still feels like a subset to me. Like trust domain feels like a subset.
Overlapping, but not necessarily.
Yeah. Right.
So I propose we take this offline because I don't think we'll figure it out now. So this can be settled offline. What is administrative domain versus trust domain and how they overlap and so because
we can settle on the PR. I agree.
To the next topic, we only have 14 minutes left. This multi-mesh and federation can easily take a few hours of somebody. So we can continue next meeting. Please feel free to bring it up again.
The PR should be merged by next meeting.
Okay, all right, hopefully, yes. So that's why if we can converge offline, that's great. So John,
literally that discussion we already started, Nathan started in the PR, so we can continue that trust domain thing.
Okay, great. Thank you very much, Frank. So John Fei, okay, he's already presenting.
Hi, thanks, Sandra. So I want to discuss a little bit about a proposal that is trying to simplify the mTLS adoption user experience. And here is the design doc. And I received a lot of feedback. Thank you, folks. And I think two things that is I would like to discuss are following. The first is about how we can, what kind of, this proposal is designing some mechanism from Istio to simplify the customer to adopt mutual TLS when they're in permissive mode during the migration phase. And that feature obviously need some configuration knob, either a control plane flag or an API to
guys, sorry to interrupt. Could we actually present? Could we show the design doc on the screen?
Yeah, we already did, I believe.
Or maybe Janfei, give a short overview about that, because not everybody had time to look at this before. Like just what to start.
All right. So the problem today is that we need to configure too many things to adopt the mutual TLS, and especially when we think we can do better, and especially in the permissive transition mode. Then sometimes the server side does not have, or they have the Envoy sidecar, and the customers need to figure that out themselves, and they need to enable destination rule and authentication policy, do it twice to adopt the mutual TLS. And so we are proposing something to tracking the endpoints in the pilot to do that thing, configure the Envoy automatically for our customers.
Quick question here. You said two things, but they don't have to configure two things. By default, we ship out of box with TLS in permissive mode, and all you need to do, all the user need to do is to set destination rule, no?
True.
So there's only one thing, destination rule, and
but if you true, but there is when you lock down to strict mode.
That's a different story.
Yeah. Okay. So there basically there are some API improvements and mechanism improvements for the permissive mode, and the API improvements can be done on the API side. So there, and this design is proposing a feature in the pilot to tracking the endpoints, and this feature needs some option to guard that. There can be different options. The first one
actually, I'm sorry, Janfei, I don't. What are you trying to accomplish? Like, how is this better from the current system? What are you trying to do?
I'm trying to make customers to write less configuration to opt Istio mutual TLS.
Well, to perform the number of configuration steps that a user has to go through to move from basically permissive mode to strict mode,
right,
end to end,
yes,
is extremely onerous right now.
Yeah, and also to know along that path, Greg Hansen here, I'm working on the mTLS autopilot request is out there now for people to provide some feedback on. But the big thing in that upgrade scenario from permissive to strict is any destination rules that they have in place actually end up breaking the communication that they had in permissive mode when they transition to strict, because they most likely do not have a TLS block defined in those destination rules. And so basically one of the benefits of this pull request is if you're in strict mode, when you have a destination rule and no TLS block is specified, it will use the Istio mutual mTLS.
Which is it? This is your own pull request, or is this a pull request that influenced part of Janfei's? This is independent.
This it's part of this design proposal.
Okay, cool.
Yeah, so I think there's multiple problems. So first problem is what Greg was mentioning. As the user transition from permissive to strict, they have to add this TLS configuration in destination rule, and that surprised everybody. Second problem is today, if you go through our installation guide, we always have two tabs, one for permissive, one for strict, which is extremely confusing. And almost a lot of our profiles, we also produce one for permissive, one for strict. I think it confused a lot of people. Yeah. It would be really nice if we actually just have one mode, and then later on when users feel extremely confident that they can lock down for security, and then we can just toggle through the strict mode instead of like two modes at the beginning for user to play with.
And there is another discussion about we still have about readiness probe, and it's coming back with a new filter chains. maybe we can, as Lynn said, maybe we can have a single profile that is, by default permissive, and we keep permissive forever. And we don't switch to strict, but we put an authorization rule instead of authentication rule. So basically, if you don't want to accept plain text, you specify it as a, anyway, that's a separate discussion. We'll come back because there are some problems we are encountering now with strict mode and the new features. But sorry,
but I think you are onto something. I was thinking mentally as a user, I just want to be one mode, and then later on, when I know it's going to be, I can enforce everything
exactly
strict. I can just do maybe apply a resource or a simple configuration, and I don't have to reinstall anything.
I completely agree with you. That's my point as well.
Okay.
The main benefit of this proposal is that it allows us to remove the strict mode profile from the installation and all the other.
Right, but it's not actually reflected in this proposal, which is why I asked Jianfeng to present to the group. And also, if you look at this proposal, it introduced a new mode. I'll let Jianfeng talk, which I think is extremely confusing. Having another mode for people to learn, another TLS setting for user to learn.
So, okay, I'm trying to attack the second question first. So because this proposal is introducing a feature, and this feature, of course, we need some configuration knob to turn it on and off. If that is not an API, what are the alternative thing you can think of?
I don't think that was Lynn's issue. She said you are adding yet another option to that enum in destination rule.
Right, right, but that's what Jianfeng means, Shriram.
No, there are different ways of API enabling this thing, right? We used to have a simple global mesh config boolean that said like yes or no for mutual TLS, and which could actually be changed into permissive or strict, and it's just one top level boolean toggle that when enabled, it just automatically enforces strict mode for both clients and
right. But we're trying to move away from using flags in mesh config to using APIs.
It doesn't matter, but you can just create a separate CRD and so on. But the whole point is it's just one Boolean flag. You don't need to have in two different touch points or multiple different places to coordinate. It's just one Boolean flag to enable.
Shriram, I'm not disagreeing. Nobody's agreeing to have a flag in mesh config. I mean, I think.
No, it's not for the flag. I was telling him that it's just one single place of configuration where you can just create a separate CRD for all I care, but you don't have to touch
so basically, let me try to summarize. If we are, instead of adding a new mode in the destination rule, we put it in another CRD place, a single Boolean. Maybe
in mesh config.
Right. So we already have two configurations for global mesh behavior, right? One which is to put a resource in the root namespace.
Yeah.
Right. And we have a resource to represent this state, which is destination rule. Right. So let's
right? Or are you talking about the wildcard destination rule?
A wildcard destination rule in the root namespace acts as a default.
And there is a second issue, which is global settings. I mean, everything that is a flag install option or a mesh config option applies suddenly to the entire cluster at once. There is no way to do a gradual adoption. There is no way to test. There is no way to.
We can always break it down by namespace and so on and so forth.
Right, but then we already have an API.
That's
the same point. Right? We already have APIs to represent these concepts that are scoped.
Yeah.
Yes, but we already have an authentication policy that says strict, and so if it's strict, we can enforce it on both clients and servers alike, and there is no need to add yet another mode to destination rule.
That's part of the problem. There is another part of the problem. The new behavior in the permissive mode this design is about. That is also that new flag.
Right, Shriram, we also have situations where there are endpoints that we do not control. Right, and you still, from a security posture standpoint, might want to force the client into strict mode, even though you have no idea what the server is doing.
That's fine. You can still use the same authorization policy, that authentication policy.
The authorization policy is server-side only.
Yes, but change the semantics of it, and just simply say like this
That's a huge change to the API.
And doesn't make
sense.
But
you can just simply say like this is the mTLS policy for the cluster, which says strict mode on both sides. It's a strict mode or permissive mode. That's it. You don't need to have a strict mode on client or permissive mode on client, and that's just too much.
Right.
Permutation and combination. This is what led to the whole
Right, but the point is to get the
I don't see why we need to have a destination wildcard. Just to say that you have it like for all services. It's enough to have a single Boolean for the cluster.
No, how is that any different?
It is very different. Destination rule is a pain to like understand, and the inheritance and so on and so forth. We have a whole bunch of issues with that. Why should somebody need to learn that piece to go and enable this? I mean, the security piece is somebody else's problem. So
we've already done this pattern to users. We already have an API to represent this concept. We have to support variability of behavior on both sides for both client and server.
Why did you need to have support of variability?
Because there are servers we don't control and clients we don't control.
Sure. And for servers that we don't control, the destination rule already has a TLS setting where you can actually go specify single one-way TLS or no TLS, right?
A set is very composed of both.
The interpretation of destination rule today is to affect the client behavior, right? It's overridable on the client namespace, right? Which means that, right, unless you mount services that you don't control, if you mount them in another namespace, you can override the behavior of their destination rule.
And modeling destination rule.
So remember, the goal here is to get to the point where there are two settings, right? Where the default behavior at the runtime is either strict or permissive on the server side, and the default behavior on the client is either strict or automatic on the client side. And those are effective globals.
And I would say that the concept of having opportunistic mTLS, opportunistic encryption, is well defined and well understood at least on the internet.
That's a third topic.
It's not a third topic because this is equivalent. So basically what we're saying is we have a mode which is TLS, initiate connection and TLS, one mode initiate connection and plain text. And what we are adding is initiate connection as the best you can. TLS is if possible, otherwise plain text.
And remember, the default installation out of the box would be
plain text,
permissive on server,
and plain text on
and auto on client.
Auto on client, right?
Right now it's plain text.
No, I'm saying
but we want it to be auto. Yeah.
In the new world.
Yeah.
That's what you would have. And as you rolled out sidecars, you would never change any settings.
Yep.
Right.
So are you saying the new mode, the auto would be the default, and maybe eventually?
Right. So once again, then this again
auto.
means you now have to implement inheritance the destination rule and make sure that like anybody that overrides the rule needs to copy the auto mode. Or if they don't, then you go through some more hacks, like add another PR to go fix that and try to automatically infer this thing from some root rule and all the usual stuff that comes in. Or you go
how is that any different than inheriting them from a config map flag?
And we're learning the values of YAML and...
Because if you take the sidecar option, like you can just simply stick this as like, a field in the sidecar that simply says all clients from this namespace should initiate mTLS, and that's just one single Boolean flag and you're done. That's it. There is no need to refer to destination rule for mutual TLS.
That's fine too.
Well, let's leave aside the fact that we haven't yet resolved the destination rule API with sidecar and/or service entry, which is a pending discussion. But currently, destination rules where we put this information.
Yeah.
No, but I agree with Sirab on that because we don't have the inheritance model for destination rule.
But we can.
We do actually.
No, we don't. We actually only have an override model. We don't have an inheritance per se model.
You inherit them like from port, like port specific inheritance from that.
Right. So we might need to change that.
Right, but see, the amount of things that you're touching to change just this piece is a lot more compared to like adding it in one scope system called sidecar, which says I just want to initiate mTLS always for all clients for which the sidecar applies to.
But it's not always.
That's true. It can't be always.
We have always.
From the client side, you can have a flag that says I will only, all sidecars pertaining to this should initiate mTLS. That's it. From the client side.
We have that. We have a flag to say always with mTLS, but that flag is not
on
good.
the client side, not on the server side. Where do we have such a flag for on the client side? There is no such flag. Destination rule is not a flag. That's the point of discussion.
Flags have the problem that they are global. I think with the new installer operator and everything else.
Sidecars are not global. Sidecars do have.
Sidecar is good, but not globals. Let's not confuse. Sidecar is an API that we define. It's an API like destination rule. I'm fine putting it in destination rule, sidecar, wherever. It's fine.
That's fine. We just haven't resolved where this particular feature of the API space lives right now. So absent resolving that discussion, which is a largish API change, destination rule is currently the thing that dictates the client-side TLS behavior.
And we can move it to sidecar.
Yeah, I'm fine to move it to sidecar, but it's just a bigger discussion.
If we move it.
So can we move it? Because destination rule is overloaded. It defines subsets. It defines TLS settings. It's hard to comprehend when you add one.
There are plenty of issues, like we've discussed plenty of the issues with destination rule, like subsets should probably move into service entry, et cetera, et cetera.
And sidecar is also defining a bunch of entries. And again, it's...
Right.
Yeah, but let's start with removing this like wildcard TLS from the destination rule and moving it to where it belongs.
But
like
that has a high cost.
Andrea, let's not presume that that's an easier thing to achieve in a single release timeline. Like John Fay should at least have the opportunity to go and look at that and get.
That would be a 6 months deprecation because this API has been relatively better and it's a lot of people. So that's
right.
I don't know who uses this for now. So we have like theoretical support, but do we have a concrete example of somebody who uses this?
Yeah, a lot of people use it, of course. That's one of the core features for security.
Find like a list, like some concrete examples, and let's talk with them. Like if that's the issue, like the deprecation policy, we'll deprecate it, we'll wait 6 months, and that's it. And meanwhile, we'll implement the other option.
Well, so I think just to be pragmatic, we need 2 tracks. Right, where John Fay and Greg get to work on a relatively small incremental change to the existing structural model of the API.
Yeah.
And in the meantime, there's another track, which is like, what the hell do we do about destination rule?
Yeah, I think we can achieve this goal separately and not.
Maybe you can have consensus that in the end we'll have 3 modes. We have the mode plain text, TLS, and auto, or opportunistic, or whatever it's called.
And
long term, no matter where we put it, we still have 3 modes.
And also to be clear, I think like this auto mode, once you define, we can actually deprecate Istio mutual in most cases.
No, Istio mutual maybe, but
yeah, Istio mutual, Istio mutual maybe, because customers no longer need to configure, as Greg and Lynn mentioned, no longer need to configure the.
It's not only within Istio. I mean, it's basically Istio mutual means mTLS.
Yeah, right.
mTLS with our credit.
Right. Okay, let's
go that far.
Yeah. Anybody else want to weigh in on this subject?
Can we clarify in the doc as part of the discussion what are we eventually doing in the first phase, not talking about the destination rule moving to the side control.
I think the bigger discussion there was
today.
Handling a mixed mode service, which has some pods being in, whatever, using mutual TLS and some not. And on the cluster side, you just need to initiate the appropriate connection to the destination, like whether you used to use mutual TLS or not. And for that, the suggestion was to actually add an envoy level filter within the clusters. It now has the ability to add filters in the clusters, where if you just augment that functionality, you can automatically do opportunistic TLS initiation by looking at the endpoint label within that cluster and then decide if that endpoint has the label, you can just initiate mTLS. If not, you can just initiate, plain text connection, which is
good idea. But
well, we'll have to see if the Envoy folks are willing to take it.
But they already have that functionality in Envoy as filters, and the API is not complete, but it's still evolving, and that this is the best way to add, right?
We can track that.
I simply agree with that. It's a good long-term solution, but short-term, I mean, let's not let perfection be enemy of.
No, but short-term is not. I mean, the alternative that was proposed in the doc is just not possible. That is like we can
actually,
add callbacks.
I don't agree with that part. So yes, thanks for that feedback. But I think the complexity around this implementation in Python is not as bad as we think. Yeah. We basically whenever endpoints get updated, we get the trigger the callbacks in the pilot. And we also do not need to reiterate all the endpoints during the CDS push, so that it will be very efficient and just a Boolean field when get toggled when the endpoints all have their mTLS label. And then CDS push will just look at that field and do the thing. That will be not much different than today's time complexity or the space complexity.
So most of
that still doesn't answer the question. What happens if 3 out of 5 server pods are mTLS and the other 2 do not have, and the client needs to do mTLS for 3 and the non-mTLS?
No,
that's not the design.
That's not the design.
Why isn't that part of the design? Because that's still part of the same. If I'm just slowly rolling out the server side thing, why should I break?
The choice is you pick a heuristic, right? At which point you toggle the entirety of the service from one mode to the other, and you don't serve the endpoints in the other state.
Right. You only have that, all the endpoints have that label, then you toggle the client.
Or the plurality of the endpoints.
Right.
You have a choice, right? It's a heuristic.
It is heuristic.
Yeah, that's something I feel the doc wasn't clear. I'm fine not cover that scenario for now.
And to be safe for the first release, because again, there is long-term and short-term. For the first release, probably the heuristic will be 0. I mean, if you have, but long-term, we can do what Shriram wants. That's definitely a good idea to do it long-term, but let's ship something first.
I'm not totally sure, because the other thing that has to happen is somebody has to be able to audit the state of the current system, and the way to get that information out to make the decision to turn on strict
telemetry
is to know what pilot is doing.
Yes.
No, you can get it from the sidecar directly to the actual
Right. Well,
state of the
remember,
system.
Sriram, what's the operational cost for an end user in terms of tooling to get it from the sidecars directly?
Also,
all the sidecar, we have the dashboard that shows number of TLS connections versus non-TLS connections. If it's always
Right,
100%.
but for which service?
Per service,
Right, and so what happens if the
Sriram, remember that's presuming right? Prometheus, right? Prometheus, what if I'm using some other monitoring solution?
Right, but how do you actually go and audit the entire state of the system? Because
you ask
pilot
pilot.
Yes, that's only
which
a point in time statement. It is not always.
Sure, but that's also true for the telemetry solution. But at least it's hermetic, right? We can't rely on the existence of n distinct telemetry solutions to help people with an operational problem on the control plane, right? Otherwise, we kick it out to docs, right? If we're going to provide any tooling or automation around the transition district, the only thing we can take a dependency on is pilot or something in Istio CTL.
Right, and also to add that, I think there is some discussion about the data plane innovation before, and but there are also concerns if we put that in the Envoy, for example, the TCP proxy use case, the connection overhead will be doubled, and we need to validate that and maybe have some caching mechanism in the Envoy for that. There will basically, I'm trying to say that the complexity, there will be some complexity, whether it's the Envoy or the pilot. That's it's just.
But the Envoy level thing is much low, and that's how we did the TLS sniffing. That we didn't actually try to do it at the pilot level just to see if all the endpoints for a particular service are using mTLS or not, and then I try to dynamically configure. We did that TLS sniffing on Envoy for this, right? Because we didn't want to see all the clients. So why can't we do the same thing on the Envoy side for the client as well? Or why do one on Envoy, one on pilot?
But there's a different solution. One is in control plane, one is in data plane.
Yes, it is a different solution. My point is, if you're implementing the TLS sniffing, which is for the same problem where you just don't know how all the clients in the cluster are going to connect to you on TLS or not, and if you do that in Envoy, why can't you do the exact same thing in Envoy for the client side, which will be one proper consistent solution rather than having one part being done.
So Sriram, there were two proposed solutions for Envoy, right? One which was, I talked plain text to the endpoints were plain text, and I talked TLS to the endpoints which were TLS, right? The other solution was, if there is a plural, like I'll only talk to the TLS endpoints and I won't talk to the plain text ones, right? Now, from a security posture point of view, right, you have a heuristic at which point the latter is the better solution than the former. Right. I talked to Piotr and the Envoy folks a lot about whether we would implement, client-side TLS sniffing, right?
Right, but that involves pinging and trying to disconnect.
Right, it's very expensive.
This is the one I proposed was much way simpler. We are already shipping all the endpoints with the label information to every cluster in a particular Envoy. So that cluster already has a bunch of filters that we can actually add, and all we have to do is, when we're about to make a connection to a particular endpoint, we have to check if that endpoint has the label mTLS ready. If it has, then we turn on the TLS code when we finish it.
That requires contemporary changes.
Remember, Sriram, you still want to do the heuristic thing, right? How do I get to the point where?
But you can do it in cluster. I mean, what she's saying is not. I mean, it's.
No, I understand, but it has to be able to enforce the heuristic. Right.
Yes, but we can.
When I stop talking, how do I stop talking to plain text? It has to have that feature.
Right. So that we can enable from the control plane, where we can decide to not even configure that filter chain for a cluster, and always say this has to use mTLS, and that's it, done. Whereas the other option is, but in this mode, we can actually properly support mixed mode servers and mixed mode clients without touching much of configuration. And as these things can go up and down, it's much easier. Scale and scale out. I can debug things nicely in a non-strict mode, because I can launch a pod without TLS thing, and I can actually see the traffic, do TCP dump, do whatever it is I want. And these are benefits that I like there.
That's perfectly fine for a V2 of this proposal, but in the end, the semantics, I mean, we still need an API to control if you do this or not, because it's data plane and everything
the API
is
simple. I mean, the
it's the same API, really.
Complexity in pilot is you're underestimating in terms of going and doing selective CDS pushes, during which time some other pieces of configurations could have changed, resulting in a more inconsistent data system.
So Sriram, I don't disagree, and if we can get the feature in Envoy, I think that part is fine. I think the other point is that no matter what, the API is still the same, right? Because they're both runtime implementations that are black box, Right?
Sure, yes. I mean, the API is same, and we can do the API either with sidecar or changing the destination rule in a different way.
Yes. And we can have one implementation now, one implementation when envoy is ready. And then we can compare that.
Yeah, but I think the one implementation now is going to be a half-assed implementation that's going to come out with several deadlocks and races.
Same for the other.
No, actually, that one will not have deadlocks and races.
So
this had deadlocks and races.
I'm fine. Shreera might actually be right that doing the implementation in Envoy is cheaper for that use case. Now, Shreera, how do we still have to have the problem of automation or tooling around the transition to strict that's not dependent on a telemetry solution?
And I propose to have both implementation and compare the data cost, because in data plane with permissive we have some delays that we add. I mean, it's never so clear that
that's fine, right? I mean, you're already providing a transition which is much better than take down everything and start.
Sure.
So
that's not a thing. I mean, the tooling, I agree. We can definitely build tooling. We can definitely build heuristics where pilot can decide to even set up that filter chain or not set up the filter chain, which is a way of enforcing strict or no strict, and getting the additional metrics, which is Quad is actually doing it. He's actually collecting cluster level telemetry by adding those additional filters. And so you will be able to collect those telemetry, which can come to pilot or some other place, which we can aggregate and send it as one.
All right, so let's segregate the doc. We have two runtime implementations proposed.
And
they can be dueling banjos, that's fine.
Yeah.
We need a solution to the, we have to decide what we want to do on the tooling side. If we want to give usability support, right? Like Istio CTL, can I turn on strict? Right? And how we're going to meet that requirement with either of those two implementations. And then there's the API thing, which is independent of all of that.
And
independent of
I've been working on this Istio control inspect command, which is partially automated, partially heuristics, and it tells you what the current settings are. I could easily change that to give you some hints about whether strictness could be enabled or disabled. Would that be helpful?
Yep.
Okay.
That would be really helpful, yeah.
So I have one concern on this thing. So now the client setting rely on the authentication policy of the service, of the destination service.
No, it's relying on whether the server has or doesn't have mTLS. It doesn't matter. It can be a non-Istio client. It can be anything.
It also need to know that it's the permissive or strict mode as well, right?
It only cares if you have mTLS or not on the server side. If the server has mTLS for whatever reason.
The grid that is the document somewhere. We have a table where the strict mode is only have the mTLS, and when the permissive mode you based on the label, right?
Sure.
So we have that. This is a bit different flow between permissive and strict.
And how will that be a concern?
So it's working okay now when the authentication policy is service oriented.
Actually,
we are moving
I thought about that as well. So that is not a concern, because if you are defining using workload based authentication policy with mutual TS, only select a subset of the service to be mutual TS. And,
no. I mean, so when on the client side, when you say you need config for the service full, right? You also need to collect all the workload for that service full and see what the authentication policy mode is, what the TLS mode is, right? It could be a mix of strict and
it could be mixed, and I think the right handling is if one of them is strict, then we take it as strict, because it does not make sense if you configure a service to be one work to be strict and the rest to be plain text. You will have breakage anyway.
Sure. What I mean is it's not clear.
Okay. We should clarify that. I have that.
But the user doesn't have to worry about this. I mean, if the user specifies auto, we do auto. That's
they do auto on the client side, but it's need based on the strict mode.
Some servers will fail. Okay.
I have one thought on the Envoy part of optimization. It might be good in terms of performance and scalability, but from a user's perspective, I think
it's the same thing.
No, if anything goes wrong, it's in the autopilot approach, you can look at the Envoy configuration and have an easy way to reason about whether it's using mutual TLS or not by looking at the TLS configuration. But if it's a data plane innovation, it seems very user has to go one level stack lower to debug this, and which might be harder to troubleshoot.
Well, both of them are hard debugging.
Yeah, I mean, I would not buy the debugging.
So why
Debugging
don't
is
you document all these like pros and
sniffing
cons?
is already a hard one to debug. You don't know if it's being using mTLS or not using mTLS. And on top of this, it's not.
But I think we agree. I think everyone seems to agree that we need this feature. It seems to agree that it needs to be an API. Destination or sidecar probably that's something to be decided. And in the end, we'll have two implementations. We'll evaluate. We choose the best. We make it both if necessary. If there are trade-offs, there is nothing wrong with implementing something now of the implement. Even if it's not perfect, and have a better implementation later because it will take
some time
to release it down.
Yeah.
I was under the impression.
No, Envoy will not take 2 releases. Like, I agree with Sriram that that's not the case.
Yeah.
To have a stable implementation.
I mean, a stable implementation pilot is also not that easy. I mean, we are still fixing deadlocks and race conditions in that EDS code. I'm telling you, like, it's just not that easy to simply stabilize. And
because he would have to do the transitional push for CDS as well. So he's right about that part.
I don't know which one is safer. I mean, let's not forget how many problems we have with permissive mode with in different corner cases and.
But it was much less than the amount of things we already have at destination role. It was like MySQL breaks, Mongo breaks, others do not break.
I know.
Whereas here,
6 of one, half a dozen of another. Like doing this in Envoy will help more people than just the Istio people.
I know.
There's that.
There's that.
We don't want that.
Okay.
But again, there are a lot of things that break. I mean, there are all kinds of cases that break even today with Mongo protocols that use TLS.
but which we have fixed, right? That is easy to. I mean, so it's very limited. Mongo, MySQL, and
so my guidance would be, I think Sriram's probably right. Doing that change in Envoy is probably easier. So why don't you go talk to John and Piotr and Quad?
Okay.
And get some kind of estimate. And separately, we need to talk about the API, and separately, we need to talk about the user experience around the transition, right? The stuff that Ed.
Okay.
So didn't we just agree about the API that's going to be in the sidecar and not in the
No,
destination?
we didn't.
No, absolutely not.
That's phase 2.
I mean, some people have this opinion, but that's big.
But for now, destination rule seems to be what we already have, and the design doesn't have to be depending on that.
And when it moves, it can move with the 3 fields and or 4 fields and
Okay,
so it's going to be a new enum or what?
A new value in the enum. We have an enum with 3 values, will be 4.
Right.
Or 4 values will be 5.
I guess
that we need a new enum and also import that inheritance model, right? Which is that.
Yes, the inheritance.
Which we need for other purposes.
But it doesn't be a problem because it's maybe not backward compatible.
Why?
We've had so many issues with the inheritance or derivation models, and that we have changed the behavior and destination rule already twice this year.
Yeah, I didn't know that, but sure. Okay.
One was with scoping and isolation, and the second one when it was completely shown to be completely broken anyway.
Cool.
Okay, so we're severely over time, 20 minutes over time. So, Jean-Fei, do you think we can reconvene in 2 weeks on this topic with some conclusion? Do you think that will give you sufficient time?
I think the TLDR here right now seems like the API part is more or less agreed on the destination with the inheritance, and the implementation side. The more data on the Envoy side will be good, but we can do things incrementally, one at a time.
And maybe a prototype will help. I mean, if we have a prototype PR and the branch where this is implemented to evaluate how it works, it will simplify the decision because we'll have data. I mean,
we can measure. We can try it.
Put it as a load test.
We can try it and simulate a large workload and see how this can be reliably used for a release qualification setup.
I don't think that still does not handle a scenario of all the missed updates and missed sequences and deadlocks. So that you need to run to actually release to the end users, go through the issues that people present, and then decide, okay, this is not going to work. So it's.
But we can run the performance cluster for a while. We can give it to users as an option to test from the branch. I mean, we can create an experiment.
And that just applies to all the feature, right? Everything that we ships that we always get a surprise from customers' feedback. That's not particular to this feature, I would say.
So for the prototype, isn't that what Greg already has?
Yeah. But
the control plane side to do.
Yeah. But the concern is raised about the stability and the race condition dialog in the pilot that will be better.
Hypothetical, yeah.
Yeah.
And for that, we need to test, basically.
Yeah, basically, we need to have better tests.
Right. And we could dark launch that first, too. That's always an option so that people can actually test it.
That's a good point.
It's off by default, so it's not a problem. Users will just get it when...
Yeah, dark launch is a good idea.
Could I ask a question to clarify the intent of this feature? And that is, when I hear that there's an intention is to have a global option to enforce mTLS client side to all destinations, and I'm wondering that during the transition or during the execution of that, is it possible to understand whether the destinations are yet mTLS or not, and assuming that the destinations sidecars are being updated to support mTLS, that the connections to the destinations are mTLS when available, and might be plain text if it's not yet available, with the assumption that those destinations are rolling and will achieve, will converge on all being mTLS. My concern is that during this transition, we're limiting the number of destinations and thus bottlenecking the availability of those destinations.
That's not the proposal. I mean, the proposal is to, there are two proposals. I mean, Shriram proposal is to continue to do plain text to workloads that are plain text and mTLS with those that are mTLS. And this one is to, if any workload is plain text, do plain text to everyone.
Yeah.
But we'll always have the entire set of workloads.
Right. So I think that there's a range of heuristics here, Shannon, right? Where you can be in those two states. You could also be in a state where you look at plurality, right? If you weren't as concerned with availability, right? There's a debate to be had probably in the design doc about whether there should be user control over the heuristic.
Yeah.
Right. It's in either the Shriram proposal or the Janfe proposal, right? The cutover to being all TLS, right, and then forcing TLS, right, is triggered by some event, which is usually in this case all the endpoints being mTLS. There are some people out there who are more worried about their security posture than they are worried about their availability. And so they would say, look, if 80% of my endpoints are mTLS capable, then I want to cut over. And I'll force my clients to use mTLS, and therefore I won't talk to the servers that aren't. Because they may have some corner case where they haven't been able to update a service somewhere, right?
Which is equivalent to turning strict mode now, and plain text will just fail. I mean, we will just stop talking with them. So that's,
well, that has some interesting, we haven't validated that doesn't have side effects yet that we are uncomfortable with. But in essence, yes.
Okay, just to confirm.
Right, so if we did anything in the data plane would have to be able to toggle between those modes, between effectively a client-side permissive mode where it will talk whatever the endpoint will support, and strict where it will only talk to the endpoints that support mTLS.
And then we go back to pilot, because pilot is the only one who knows what is the story, and you cannot do local avoidance, and then get back to the same complexity.
Well, you can.
Well, you can, yes. Well, you need to.
Right, that becomes a little tricky if pilot, for instance, is making subsetting decisions about only sending a set of endpoints to any one envoy, and not sending all the endpoints to all the envoys all the time. We're not there yet, so it may still be easier to do the solution in envoy. Then we might be in situations where there's still some intelligence in pilot over time. And does that answer your question?
Yes, it helps. Thank you. At least within the mesh, it seems like one could have confidence that all the endpoints are mTLS, and thus, but during the transition, let's say I've flipped a switch that says I want mTLS everywhere. You're going to have maybe sidecars rolling or containers going up and down, and during that time, you want to maintain availability of all applications in the mesh. And you have the intelligence to know which endpoints are mTLS and are not.
Right. So currently, as stated, the doc is the heuristic is 100%, so the availability is maximized.
Right.
During the transitional phase.
Sorry, I don't know what you mean by 100%.
So until all the endpoints have reached mTLS capable, right, we'll talk to all the endpoints in plain text, or so in either form.
Oh, interesting.
Right.
Okay.
Sriram's form is I'll talk to the endpoint in whatever it supports, but it still has the same net effect from an administrative point of view. Because endpoints can still transition back and forth between plain text and mTLS capable, and they'll still be talked to.
And user may stay in this permissive and auto mode forever. I mean, many users will just not turn strict and just stay in this mode.
Right, until they get a security audit.
Yeah, I don't imagine that being a desirable state.
Yeah, right. So one thing we have to do is to make it from a user experience standpoint, we have to make very clear that this is a transitional state for most people.
Right. Otherwise, they are not caring about MimikRT in the first place.
If they don't have RBAC rules, then it's basically kind of
No, there's the
It's
people
like
who have
that.
compliance requirements who just want to be encrypted end-to-end.
Oh, compliance, yeah. If they have compliance, then of course they need to have strict, and there's no discussion about it. But many people don't.
Cool. So can we say that if we can try this control plane approach and make some measurements, and meanwhile we can work in parallel to see how estimates the amount of work that needs to be done on the Envoy side?
I mean, we need to test it, of course. We need to test it, and then if it works, I mean, the API is agreed apparently, more or less. So if the API is seen, I don't see any problem with having an implementation and testing. And it's a better implementation when it becomes available, we can compare, but I don't think we should stop.
Yeah.
Rui, what do you think?
As long as you don't merge it, I don't really care. You can spend the time, but
no.
I do not want to even merge that thing as an experimental thing, because the way it goes is that like you would merge it and then you would leave, but then somebody else would come and break that if else block, and something else would happen, and then things would just leak. And one day we'll end up scratching our heads just like, why the heck this is actually happening?
That's proof of all the changes.
Right, but this is like a really huge change. It's just amplifying the amount of like deadlocks and this thing, and it's like it is very painful to go and debug that. Like we've had people who are scratching their heads on like so many times, looking at everything only to find that this update was missed. It's really painful. It's not an easy, and this is actually embarrassing when you go to the customer and then they're like, I thought this is all working, and then you're like, whoops.
Let's not get too much into the weeds about blaming one piece of the runtime or another for being
I'm not saying it's bad. I'm saying when those things happen, it's actually very hard to debug.
But if it is,
I think we have the ability to debug it, and we can just
if it is protected by a flag, there is no change in behavior. So as long as a flag is protecting,
if the concern is really about the complexity, we can even make the.
Let's do a complexity assessment.
Yeah.
Right, we can do that. Right? We can go talk to people like, hey, what would it take to implement this feature in Envoy, and would the Envoy community onboard it? If the Envoy community says, no way in hell are we taking this feature, then we're done.
No, but we have filters. So the filters are
no. But Sriram, if we can't implement it with a filter or something else, right? So let's go do the assessment. Let's not presume the outcome.
Louis, what I hear from Sriram is that he has concerns on how this will look in the pilot code. So if Android cannot do it, it doesn't mean we have to do anything.
So let me clarify as to what I meant in Envoy. We only have to add the appropriate abstractions in Envoy to be able to change the TLS settings. We don't have to actually move the piece of code into Envoy at all. We've made plenty of changes in Envoy to be able to tweak 10 different pieces of all the core areas of Envoy. So once we have that,
it needs to be done in detail. That's all I'm asking for.
Yeah, I agree. But I'm saying that Matt is open to it because we actually saw and we actually decided that the API that we have for the cluster level filters is still not complete, and it will only emerge through use cases. And this is a perfect use case for that. And today the API is pretty much like what we had for the network level, the listener level filters. But once we change that, it just becomes a much nicer way of and we will hold a filter. We should not even push it onward because that's just not worthwhile for them to host that. And just like the way we have additional filters, we'll just have this as well.
Well, even the whole filter chain is not completely, it's very alpha and not clear how reliable it will be, and we still find all kind of problems. So let's not assume that something that is on paper and we're waving the hand is perfect, and something that is concrete is bad because hypothetical, it will look bad. As long as I have the flags that are completely off, I don't see any risk.
I totally disagree with this, that the flag will prevent mayhem. Okay, so what I would like to see is a good design for this, and I would like to
that's a design, Andrea.
I'm documenting his concern about the possible deadlocks and what will happen. right? So I don't think we can go ahead with a feature that looks bad, like from a design perspective.
The design, there is no question about the design as far as I know, just that in the implementation may have some.
Yeah, may have.
Well, that's design from my perspective. Like if this will cause deadlocks and problems, let's try to identify those. I don't think we can go ahead just like that, you know, like.
Well, no, they can. People can always create a PR. Yeah. Right, but we should, like, I'm asking for the two solutions to be documented with a reasonable level of detail.
And if there is a deadlock, it should be identified as a PR, not in, hey, any change can have a PR, a deadlock.
We can agree not to commit the PR.
Some of the deadlocks could be identified even in the design phase, right? So whatever it is, but I don't think that code can be merged. Like if Shuram, for instance, has a look and he sees issues with that.
But I'm happy to address if there is any specific deadlock pointed out in condition A, B, and C, the deadlock will trigger.
That's more naturally dealt with in the PR.
Yeah, that's more naturally done in PR.
The real question is, should we spend our time doing that one PR or the other PR?
But apparently it's done. I mean,
that was my point, that we might as well invest that time and effort in the other one and onwards, such that this one we can have it ready.
Right, so
and launch
different people.
So Sriram, can you put a section in the doc about that and fill in some detail, please?
Yeah, I will. Yeah.
Okay.
Okay, so let's try to reconvene in 2 weeks about this topic. Hopefully we will have some updates.
And I'm very happy to not have any more change to pilots that can have a risk of anything, of deadlock, of behavior change, because we had a lot of problems. I agree with Sriram.
Okay.
So we need to be very careful what we merge. But that doesn't mean we cannot make any change. I mean, that's...
No, but like, we have to be careful still. No. All right. Well, I think we'll stop now. We are only 33 minutes over, so thank you very much.
Maybe we should make it 2 hours next time.
A full hour for this topic. Yeah. So, but
thank you, guys.
We'll reach some conclusion. Thank you, John Fei, and thank you, everybody. See you in 2 weeks.
Thanks.
Thanks. Bye.
Bye.